Okay, this is 5.3 homework help. First problem gives us cosine of two angles added together. So we're going to use our sum formula, which is right here. It's on the formula sheet, by the way. I'll pull that up for you. Right here. Cosine of sum and difference and sine of, these are the two formulas we're using today. So we have a cosine in this case, so we're going to use that formula. I'll show you how to use it. Pretty easy, you're just going to plug and chug basically. So for the first one, we have the cosine of x, so here, cosine of x plus 20,000 pi. So I'm going to call this u, I'm going to call this v to follow the formula. I have a plus, so I'm sticking to the top row here, so I'm going to use a minus sign right here. And I just fill out the formula. So it's cosine of u, which is x, cosine of v, which is 20,000 pi. And then I gotta stick to the top because I'm using the top signs, so it's minus sine of x, sine of 20,000 pi. Alright, so this simplifies pretty quickly here. If you look at the unit circle and where we're at with 20,000 pi, it's an even number of pi's. We're looking at that spot right there. So obviously at there the cosine is 1, and the sine there is 0, which obviously this then cancels out and simplifies to cosine of x, which we could call capital C. Now for the next part, all we're going to do is change this to a 1. So I'm going to change this number to a 1 right there, and this number to a 1. So all that does is change where we're at with our angle. We're adding, this angle right here is now here, right? And the odd number of pi takes you here. And at that point, this is -1, and this is still 0. So everything else stays the same. It simplifies to negative cosine of x. So we're going to say negative capital C there. Okay, similar problem. Tangent's really sine over cosine. So I'm going to make this sine of 75 over cosine of 75. Move back here. And then I'm going to make this sine of 45 plus 30 because we know the exact values for those. And then cosine of 45 plus 30. And I'm going to use our sum and difference formulas, our formula. So here they are. I've got sine up here and cosine down here. So let's do the top first, sine. It says that if I have plus, I'm going to use a plus sign here. So it's going to be sine of the first angle, 45, cosine of the second angle, 30, plus cosine of the first angle, 45, sine of the second angle, 30. And then at the bottom, I'm going to follow this formula. So cosine of the first angle, 45, cosine of the second angle, 30. And then I got to do a minus sign, stay in the top here with the signs. And then sine of the first angle, 45, sine of the second angle, 30. All right, now I just need to simplify this. So sine of 45 on your unit circle is square root of 2 over 2. Cosine of 30 on your unit circle is square root of 3 over 2. Plus cosine of 45 square root of 2 over 2. Sine of 30 is 1/2 all over the bottom, which is cosine of 45 square root of 2 over 2. Cosine of 30 once again, square root of 3 over 2. Plus, or I'm sorry, minus sine of 45, square root of 2 over 2, and sine of 30, which is 1/2. So the tricky part is simplifying this to get it to look like this. But it's pretty straightforward. If I can factor out a square root of 2 from the top, leaving the square root of 3 plus 1 all over 4 if you multiply the common denominator. Same thing in the bottom, factor out a square root of 2, this time you have the square root of 3 minus 1 all over 4. Now instead of dividing by a fraction, I'm going to multiply by the reciprocal of this fraction, square root of 2 times square root of 3 minus 1. So I just move that up and flip it. So I can get rid of this, and then cancel this, and I'm left with square root of 3 plus 1 over the square root of 3 minus 1, which is the form they wanted it in. They're asking for a, which is 3, and b, which is 3. Okay, the next problem wants us to find the sine of x minus pi, so I'm going to use this formula right here, use the bottom now. So u is x, and then v is pi. So I have the sine of the first angle, which is x, cosine of the second angle, pi, and I'm in the bottom here with a minus, so I got to stay with the minus here. Cosine of the first angle, x, sine of the second angle, pi. Alright, just need to simplify that and to get it to look like this. While the cosine of pi is -1, so this turns into -1, while the sine of pi is 0, so this cancels out, and I'm left with negative sine of x, which they want -1 then for our a value and for our sine. Okay, the next problem gives us this expression here, And obviously we can compare that to our formula for the cosine, sum of two angles here, and you'll find that u is 3 pi over 7. And then we have a plus sign here, so we're in the bottom, so it'd be minus the other angle v. I'm just working backwards in this formula, 2 pi over 21. So we just need to subtract these two angles, so we want a common denominator, multiply the top and bottom by 3, and you get 7 pi over 21, which simplifies to pi over 3. So this is really cosine of pi over 3, if you use the formula, and that's what they want here, so a is 3. And then that unit circle is 60 degrees, and we know that the cosine of that value is 1/2. So also they want b here, which is 1 over 2, so b is 1. Okay, the next problem gives us the tangent of pi over 2 minus u. So we want to use addition and subtraction formulas to simplify. So I'm going to write it like this: tangent sine over cosine, and I'm going to plug in with our formulas. So I have the sine of u, which is the first angle is pi over 2, cosine of v, which is u, and then I have a minus, so it's going to be a minus here, cosine of pi over 2, sine of v, which is u in this case. There's u and there's v according to this formula. All over in the bottom I have cosine of pi over 2, cosine of u, and then I have a minus, so I'm going to go to plus in the bottom, sine of pi over 2, sine of u. So now I'm going to simplify this. Sine of 90 degrees is 1. Cosine of 90 degrees is 0. Cosine of 90 degrees is 0. Sine of 90 degrees is 1. So this turns into cosine of u over sine of u, which we know is just cotangent of u. So they want to know what that is. They called that f of u. What function is that? Well, it's just u. Okay, the next problem gives us the sine of alpha is 6 over 7. So what I did is I drew an angle. It said it was in the first quadrant, 0 to 90. And I drew this reference triangle with sine opposite of our hypotenuse 6 over 7. I did the Pythagorean theorem to find that this was the square root of 13. Then I did the same thing for beta in the second quadrant over here. I drew an angle beta. Now actually beta is this angle here, but I labeled it here. And it said that cosine was adjacent over hypotenuse, negative square root of 32 over 9. Pythagorean theorem gives you this leg is 7. And then use sum or difference formulas. So the sum or difference formula is right here. Now we're using alpha and beta instead of u and v, so I rewrote it right here using the plus sign. So I stayed with the plus sign here in the top. So then I just need to fill this out. Well, the sine of alpha, according to here, is opposite of our hypotenuse. They already gave us that 6 over 7. And they gave us the cosine of beta, which is adjacent over hypotenuse, which is negative square root of 32 over 9. But the cosine of alpha they didn't give us. That's why we had to use this reference triangle. That's adjacent over our hypotenuse, so square root of 13 over 7. And sine of beta over here is opposite of our hypotenuse, which is 7 over 9. I just have to simplify that, so I'm going to make that negative 6 square root of 32 plus 7 square root of 13 all over 63. And unfortunately you're going to have to enter that in like it is, because it says that you can't use decimals in your answer. So it's going to be a little challenging to enter that in, but you can handle it. Okay, the next problem wants to find the sine of these two things added together. So we got to find these angles first of all. What is inverse sine of 1/2, and what is inverse cosine of 1/2? Well, let's rewrite this. I'm going to call this equal to some angle. I know it's an angle. I call this equal to theta as well. And I'm going to write sine of theta equals 1/2 and figure out where that is on the unit circle. Sine is 1/2 is the y value, so that's here, and we know that's 30 degrees. So I'm going to call that theta right there, pi over 6, 30 degrees. And I guess I'll call this beta then, or something else. And then to find out where the cosine is 1/2, once again, that's cosine of theta equals 1/2. Where does that happen? Cosine is the x value, so that'd be up here at 60 degrees. So that beta right there is beta is pi over 3. So now I know that I have, really what I'm solving is sine of, I'll write that here, sine of this angle, which we found was pi over 6, plus cosine, plus this angle, which we found was pi over 3. So that's really what I'm doing. Now I can use the sine formula, which is right here. So that's sine of the first angle, pi over 6, cosine of the second angle, pi over 3. Now the sine's a plus, so I stay in the top, so it's going to be a plus. cosine of the first angle, pi over 6, sine of b, the second angle, pi over 3. So I just need to simplify this. The sine of pi over 6 is 1/2 in a unit circle. Cosine of pi over 3 is also 1/2 in a unit circle. Plus cosine of pi over 6, that should be square root of 3 over 2. And the sine of pi over 3 should also be square root of 3 over 2. So this simplifies into 1 plus the square root of, well, 1 plus 3 over 4, which is 4 over 4, which is 1. So it should be 1. Now we just need to do the same thing with cosine now. So here's the cosine formula. We fill that out for you. There it is filled out. The cosine of 30 degrees is square root of 3 over 2. The cosine of 60 degrees is 1/2. The sine of 30 degrees is 1/2. And the sine of 60 degrees is square root of 3 over 2. So this ends up giving us square root of 3 minus the square root of 3 all over 4, which should be just 0. Okay, the next problem is we want you to evaluate all these. I don't have time in the video to do every single one, but I'll show you the hard part, which is getting this angle into a sum or difference. So I always do this, I convert it to degrees first, so pi over 12. To convert that to degrees, we're going to multiply by 180 over pi. These cancel and we get 15 degrees. Now once I have it in 15, it's easier for me to see then, that's really just 45 minus 30. So we're going to use 45 minus 30, which is pi over 4 minus pi over 6 for this first one. So that's just the sine formula that, on your formula sheet, which all you're going to do is take this formula that we've been doing and fill it out. Okay. So pi over 8 is another example. We're going to multiply that by 180 over pi to convert it to degrees first. That gives you 22.5 degrees, which is really 45 over 2. Now, that's the half angle formula, which technically we haven't done yet, so we're going to have to wait to do this. And I mean, it's not hard to use. The half angle formulas are right here. We are going to do this in a different section. So here's what you would use. 45 would be u, and we just plug in 45 here and simplify. But for now, we can skip that. We can skip the half angle ones. So go ahead and give this problem a try. If you need more help, I can help you during class. Okay, the next problem wants us to just use the sum formula here. So we have first angle is x, so it's going to be sine of x, cosine of pi over 4. And then we have plus, so we're going to stay in the top here with a plus, cosine of x, sine of pi over 4. And it wants us to simplify this. Cosine is square root of 2 over 2. So I'm just going to make this square root of 2 over 2. And then this is also square root of 2 over 2. So I'll make this square root of 2 over 2 here. And so what they're looking for is square root of 2 over 2 here. And then also square root of 2 over 2 here. Last problem gives us this. Let's turn that into cosine of 210 plus 45, for example. And then use the cosine sum formula. So we have 210 plus 45. Now you also could do a different one. You could do 225 plus 30 as well. But the reason why I'm doing these is because I have exact values for these. So when I use the cosine formula, I can just fill this out. So we have the cosine of the first angle 210, cosine of the second angle 45, and then I have a plus, so I'm going to stay in the top here with a minus, sine of the first angle 210, sine of the second angle 45. Now I just need to simplify this. So on your unit circle, 210 is down here, 30-degree angle. So that's negative square root of 3 over 2. And then cosine of 45 square root of 2 over 2. Minus sine of 210 is negative 1/2. And sine of 45 is square root of 2 over 2. So they just want me to simplify this to look like this, which I can do is negative square root of 3. Well, I'm going to first of all make this whole thing over 4 because I have a common denominator. So to simplify this, and double negatives go positive. Now I'm going to pull out a square root of 2, which leaves me with a square root of 3. I'll change this to, I'll flip this as 1 minus the square root of 3, all over 4, and that's what they wanted right there. And that, so it's a little difficult to simplify this, but I can help you with it. A in this case would be 2, would be this